We are going to be spending a lot of time with quadratic functions in the next 2 weeks, so I want you to be really comfortable with what these are. And let's first compare them to what we already know, linear functions. Been working with them since middle school. Now, linear functions are math sentences where the biggest exponent is 1. So if you're looking at the example here, we got 3x plus 2, or y equals 3x plus 2. And we can't see an exponent there, so that means the exponent is being raised to the power of 1. It's not changing at all. So a graph of a linear function will look like a line. And we have two main parts of a linear function when you're graphing it. The slope is 1, and that's the rate of increase, the rate of decrease. It'll be a constant rate sometimes too. The y-intercept is where it crosses the y-axis. And the standard form of a linear function is just simply y equals mx plus b, with m being the slope and b being the y-intercept. Okay. Now let's bounce on over to quadratic functions. Quadratic functions are math sentences where the biggest exponent is actually 2. So it's a step up from linear functions. So an example of a quadratic function would be y equals, let's go with x squared minus 5x plus 10, let's say. A graph of a quadratic function will actually be a parabola. And a parabola looks like a U shape. This one happens to open up, but they can open down as well. And you know, that's a little different from a linear function because a linear function will extend to infinity in both directions. Quadratic function doesn't do that. It has the endpoints that go in the same direction into infinity, but there's either a minimum or a maximum point of a parabola. And the standard form of a quadratic function is y equals ax squared plus bx plus c. And this a, b, and c, that's going to be important as we move into next week when we start working with completing the square and, of course, the quadratic formula. So now that we've got these basics, now we can start going into problems.